All right. Let me know if you need a little bigger. Welcome. We're going to be talking about graphing quadratic functions. I know it says quadrant, I didn't notice, but basically quadratic functions. So our objective, go ahead and write this down. We'll learn to graph and identify key aspects of quadratic functions. Okay, and this is part 2 of this, but I kind of wanted to review a couple of concepts. Number 1, under axis of symmetry, you are definitely going to need the formula x is equal to negative b over 2a. This is the formula for axis of symmetry. You can write it down there. Okay. And the standard quadratic form. Let's go ahead. Once y'all are good, I'm going to go to the very bottom. Are y'all okay with this? If you have this in your journal, you might want to put this on the opposite page, a little extra, so I have some extra notes. I'm going to scroll all the way down here. I'm going to just make a note here, okay? For what I want to talk to you about. Let me pull this up. Middle. And here we go with this one, 12. Okay. So basically, quadratic functions, just to kind of give you a little intro. They look like this, okay? Or they could look like this. This actual shape here, this is called a parabola. And I know that some people think that most common mispronunciation is parabola, but it is actually parabola. It's not a very pretty word, it just is, right? So that's the shape of this. Shape of a quadratic. If you were to see it in an equation, what is unique about a quadratic is that it has an x squared. So like the parent function, you know how for linear it was y equals x? Well, this time it is actually y equals x squared. That's the most basic quadratic function. As long as it's got x squared in it, and that's the biggest exponent, that has the highest degree, then you're looking at a quadratic function, okay? And I'm going to put 4 quadratics. Okay. The other thing I want to mention to you is that the standard form, do y'all remember it? For a quadratic? Y equals ax squared plus bx plus c. Remember how we used that with factoring? That is standard form. Notice how your variables, your exponents go from greatest to smallest, okay? And again, I would probably write here our axis of symmetry, the formula. Is x equals, and we're pulling the a and the b from here, right? So it's negative b over 2a, and those values are pulled from your actual quadratic equation. And the c refers to the y-intercept. What is always equal to 0 at the y-intercept? Do y'all remember? It's always the opposite. So it's instead of y, it is 0. Okay. And then you have your c. So it's equivalent. Either you write it like that or you write it as a coordinate point like that. Okay. And again, we have our axis of symmetry. Puts it right in the middle. This right here is called a minimum point. And this one here is a maximum point. Does that kind of make sense? It's at the top of the mountain, right? It would be the maximum value. Here it's in the very low of the valley, so it is your minimum value. Any questions on that? All right, thank you, sir. Okay, so I think that should get you kind of where we need to be, just a little refresher. And am I in a good position to move up? Let me go ahead and pause here while y'all write. All right, so example 4a, we want to consider this and determine whether the function has a maximum or a minimum value. So one way to double check is that if we go to our calculator and actually just put it in, negative x squared minus 2x minus 2, and I graph it, I hit the graph button. What do you think? Maximum or minimum? Maximum, because it's at the very top, okay? And so this actually has a maximum. So I'm going to put maximum. The way that you can actually tell is the value of a, okay? Right up there. So what is, because we know y equals ax squared plus bx plus c, what is my value for a here? A is equal to -1, okay? Here's the rule. If a is less than 0, okay, like this is, a is -1, then we will have a maximum value, okay? So essentially a negative number okay? It's a negative number, if a would be a negative number, and we're looking at a maximum because it's going to look like this. And to be honest with you, I think of it as if you have a negative value, then you are sad. See, looks like a sad face. Yes. All right. So if I was to go to my calculator and just take out the negative, and now I graph it, see how it looks like this? Looks like a happy face, right? And we have a minimum value, okay? So I'm going to write that in there. If a is greater than 0, then we have, that's essentially a is a positive number. Then we're looking at a minimum value, okay? And we're looking at a parabola that looks like this. And I like to think of him as being happy. He's positive, he's happy. Negative a, negative sad. Yes? Easy way to keep track of it? Okay. Let's go ahead and let's look at 4b. We're still looking at the exact same quadratic here. And it says determine whether this function has a maximum or minimum. We did that. Ooh, and I believe there is a little bit of a typo here. Wait, state the maximum. Oh, no, it's not. They actually want to know what is the maximum, what is the minimum value, okay? So let me talk to you about some steps. We'll refresh our brain from yesterday regarding some steps, okay? So I'm going to go all the way down again. See if I have room right here. Yeah, all the way down. And we're going to talk about the steps for doing this by hand. So right here. Okay. And right here. So basically these are the steps. Step 1. So I'm going to say graphing quadratic functions. Let me know if you need it larger. Number 1, step 1. Find the equation or find the equation of the axis of symmetry. Step 1. Okay. Step 2. We want to find the vertex. Okay. And if you don't remember from the first lesson, vertex is either the maximum or the minimum value. It's the very, very bottom or the very, very top, depending. Okay. And determine whether it's a maximum or minimum. Step 3. We want to find the y-intercept. That's usually pretty easy. Step 4. We use symmetry to find additional points on the graph. And then finally, step 5, connect the points with a smooth curve. So for example 4b, when they actually want to know what the value is for the minimum or the maximum, we're going to go ahead here. And the first thing that we need to do is, our first step was find the axis of symmetry. Okay, great. So axis of symmetry is a line that goes right up and down the middle, right? Do y'all know what symmetry is? Don't remember? If your face is symmetrical, it's because on one, so if you look at my face, you have one eyeball, right? One ear. It's basically, for the most part, the same. Yes, on both sides. If you draw a line down the middle of your face, that's symmetry. And so the axis of symmetry does the same thing with the parabola. Okay? Thank you, sir. So what we're going to do is we're going to use that formula. And I believe our formula was, so I'm going to write right here. Number 1, let's figure out, solve for the axis of symmetry. And then once we've done that, we can plug in x and solve for y. So I'll show you what this looks like. Okay, so it's just 2 steps. We're going to go ahead here, identify what is A, what is B, and what is C. Yes. So A is just -1. Make sure you include that sign. B is -2, and C is -2. See how easy that is, right? You're just looking at what's right underneath, right? Okay, so now the formula for axis of symmetry was x is equal to -b over 2a. So I'm going to just put in my skeleton. I'm going to replace all of the variables with parentheses, right? And then I'm going to drop in b will be -2 and a will be -1. Okay. So a negative times a negative is just a positive. We have +2 on top, and 2 times -1 is -2. And we end up with -1 as our x value. Okay. Then for step 2, so that's basically telling us that our parabola that we know is it has a negative up front, so we know it's kind of a sad face looking one, right? We know that our axis of symmetry is a vertical line, and that is actually x equals -1. But we're looking for the y value, okay? So when they ask what is the maximum or minimum value, they're actually wanting to know what is the y value at the vertex. That's what they want to know. So in order to find that out, we're going to take our x value and we're going to plug it back into here. So I'm going to go ahead, guess I'm going to have to write really small. But here I've got y is equal to negative, and I'm going to put all my parentheses, -2, again, another parentheses, -2. And we just drop in the -1. Okay. You can do all of it by hand. I'm going to actually use the calculator. And so I've got negative, parenthesis, -1, close parenthesis, square it, -2, open parenthesis, -1, close parenthesis, -2. And my value for y is -1. Right? And so the max, this is my y. Therefore, the max is -1. Is that too small for y'all, or can y'all see? All right. Take a look at example 4C. Okay, example 4C. We're going to consider this one now, and we want to state the domain and range of the function. So I'm kind of doing this little sketch, right? I got this idea. I got the idea that I've got a parabola that is facing downward, okay? I have a maximum value of -1, okay? And so I have this right here. I know that this point right here, my x value was -1, my y value was -1. And so I'm thinking if I draw a coordinate grid, I'm thinking this would be in that third quadrant, right? Something like that. Okay. So there's my x and my y axis, right? X and y axis. And we're looking at -1 and -1 right there, right? Kind of give you an idea. So for the domain, because we have, for domain, we're talking about what? Do y'all remember? Okay, we got to remember Dixie-Royd. Okay. Let me check my chat out. I got something. So, yes, exactly. Okay. So Dixie-Royd is all about domain, means it's all about x, right? So this is all the x values. We're going to look at the x axis, right? And so when I do that, I usually like to put a line at the where I feel like the line is at the smallest point and where it is at the largest point. Okay. But the thing is, it has arrows. What do the arrows actually mean? It goes on forever, right? And so let me kind of start writing this out. So for our domain, we start off with the variable x. Unless we have open dots, we have less than or equal to, less than or equal to. And it goes all the way from -infinity to +infinity. Can anybody remember what is another way you're going to see that? Because you won't see it on the test like that. You'll see it with 3 words. The domain is? Say it again. No. That's closer. All real numbers. There you go, Miss Jessica. All real numbers. Okay. Basically, it includes everything on that number line. Okay. Now, is that true for our range? Does it include everything? Nope. Okay. So for our ranges, according to Dixie-Royd, it is all about y. Can y'all see that color okay? We're going to start off with the same thing. The little number goes on the left, big number goes on the right. And so I'm going to go ahead here. Now, when I'm plotting this, is my little number or my big number? Obviously, my sketch is not perfect because it should have matched about there. But this right here, is that the big number or the little number for this? It is actually the big number, right? Even though it's a negative. Okay, so right here, we're hitting the y-axis at -1, and that is my big number. My smallest number is, it's got arrows, so it means it goes on forever, and it must be -infinity. So when we're actually writing that, we're going to drop that, and we're going to focus on this part. And we can say officially that our range is y is less than or equal to negative 1. Okay. So here's our domain, and here's our range. Yes? Yeah. Any questions? All right. Let's go ahead and let's look at the next example, example number 6. And I do realize that we skipped 5, but here we are. So this is now talking about like a word problem, right? And how we apply it. Here we got this idea where we have Ben who shoots an arrow, and the height of the arrow can be modeled by this equation. So basically he shoots it, and here we go, right? Hits the earth. We assume that's him. It's going to be my incredible drawing. Okay. And there's our arrow. So here's our equation. That's probably important. Y equals negative 16x squared plus 4. Based on this equation, can anybody tell me why did I make this look like a sad face? Because of which one?
Oh, negative.
The negative in front of 16, right? It's the negative number, so it looks like a sad face, right? So it's going to be like that. And it kind of makes sense when we're talking about the path of an arrow, right? So this y represents the height in feet of the arrow x seconds after it is shot into the air. So I'm going to label. I've got x seconds. I'm going to make sure that I label this as x, and it's in the unit of seconds. And y is height in feet. So I'm going to write that here. I got y, and it is the height in feet. Okay. Now it's asking, at what height was the arrow shot? Okay. Now, if I think about this, like I put it on a coordinate grid, right? Like right here. That's my y-axis. This is my x-axis. Can anybody tell me the height when the arrow was shot? That means right here, right? That has a special name. Does anybody know the name of that point? Guillermo? Gabriel? Do you know the name of this point, sir? No? Yes, ma'am. Good job. That is the y-intercept. Okay? And remember when we took notes earlier, we said the y-intercept, was it A, B, or C? It was C, right? And so if I do this, I got y equals x squared plus bx plus c, and I actually write out my values. A is negative 16, B is 100, and C is 4. So ding, 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 C is equal to 4. Guess what? That's my y-intercept. And if I wanted to write it, correctly, I could say x0, 4, right? So therefore, the height and we know it's in feet, so that is 4 feet. The arrow was shot at a height of 4 feet initially, okay? Questions? What is the maximum height of the arrow? So what is the first step that we're going to have to do in order to find the maximum? We have to solve for, starts with an A. What does this stand for? AOS. Axis of symmetry, right? And then number 2, we plug in X. Because they are looking for the value of Y, right? Maximum is the value of Y. All right, so let's go ahead, because this is our axis of symmetry, right? And we just want to know that. So that first part, number 1, we're going to go with the formula, and the formula is negative b over 2a. We're going to plug in stuff. I'm going to make my skeleton with all the parentheses. B goes on top. And on the bottom, we have negative 16. Okay. You can actually just put it straight into your calculator, exactly the way you see it, negative, and then parenthesis 100, close parenthesis, down, 2, parenthesis, negative 16, close parenthesis, and enter. And we end up with 25 over 8. Okay. Now, sometimes fractions are better, and sometimes decimals are better. And for this case, what do you think would be better when we're trying to find the maximum height? Because if I change this into, you know, if we were saying, what do you think, like 3.5 feet tall or 7/2 feet tall? What sounds more organic? What sounds more natural? The decimal, right? So let's change into a decimal. So in order to do that, that's alpha y equal, and then see this option 4, fraction to decimal, decimal to fraction. We select 4 and enter. So we know that right now our x, because this is for x is equal to 3.125. Do not round it at this point, okay? So now what I'm going to do is I'm going to take my original equation, y equals -16. Instead of the x, I'm going to put right here, little square, parenthesis, and then I've got 100, parenthesis, plus 4. And I'm going to plug in the 3.12. So here's 3.125, 3.125, bless you. And I'm feeling lazy this morning. So I'm just going to say -16, parenthesis, 3.125, close parentheses, square it, plus 100, open parenthesis, 3.125. It's always good to practice along if you can. Plus 4. And then enter. And I get that big number. Okay, so the maximum height of the arrow, I'm going to run out of space here, was 160.25 feet. Now, what if they asked me how long it took to get to the maximum height? What would you answer? You know? Because we know that the y coordinate of this point is 160.25, but what was the x? 3.125, right? And so that's 3.125 seconds, right? So technically, if they asked how long did it take, you would say 3.125 seconds, okay, to get to the highest point. Any questions on that? Okay. One that's really common, a lot of times they want to say how long did the entire flight take? If you are hitting the earth, what is your height? 0. And what variable is going to be replaced with 0? X or Y? Y, right? So y is your height. When it hits the earth, that would be y is equal to 0, and then you would solve that with factoring like we just did in the last unit, okay? So that's pretty much it on that one. Do y'all have any questions? All right, so that you'll be practicing Monday, and that's it for that one, okay? Go ahead and thanks for sharing this time with me. Bye.